Greetings and welcome to Science in Slippers, your peaceful haven where serenity and inquiry coexist. Before we start our celestial journey, science gently rocks you to sleep. Voyage tonight. Please let me know where you're viewing from throughout the globe and tell me what time it is now in the comments section below. I'm constantly in awe of how many of us are traveling from all over the world together. And do you like the journey tonight? To ensure you don't miss our next stargazing session, think about gently like this video and possibly subscribing to the channel. Session, which aids more drowsy brains in finding their way here. The tale for tonight is how do galaxies form such vast cities of stars? Lovely one. I sincerely hope that darkness and dust won't keep you up at night, but if it's successful, you'll at least learn a little bit more about the early universe before you have your morning coffee. So relax and you're going to glide through 13.8 as your shoulders droop and you breathe slowly. Cosmic history spans billions of years. Don't rush, the stars will wait for you. The universe was little when it started 13.8 billion years ago, not just as tiny as you'd think of a windowless studio flat, but unbelievably small and hotter than denser than a physicist's calendar during Nobel season, and the center of a star, and then, in a moment that is impossible to fully understand. It started not quite with an explosion. The Big Bang was more of a swift, elegant swelling. Despite its name, the expansion of space exceeded the speed of light in all directions. There was no flying debris. Much like when a balloon was inflated with a leaf blower set to cosmic, the debris was moving across empty space and creating itself. As it entered, quarks and other fundamental particles jostled in the universe during those first brief microsecond. With gravity always present, photons and gluons dotted about like fidgety infants. The patient sculptor started silently taking notes. It was frantic, unbelievably hot, and really uncomfortable. Not a spot to toast marshmallows or gaze at the stars. Just however, despite all of its chaos, this early cosmos had a lot of promise. The lightest and most basic atoms, hydrogen and helium, generated like cosmic Lego pieces. Breaking apart due to the intense havoc, these insignificant atoms would eventually construct everything, including planets, stars, people, pets, reptiles, and of course 380,000 years after the Big Bang. Galaxies are only in cosmic words. Something genuinely lovely occurred. When the universe cooled sufficiently, those atoms were able to absorb electrons and create the first light from neutral atoms, which had been bouncing around like a firefly stuck in a jar, but was now at liberty total at the time of recombination, which produced the cosmic microwave background, a gentle Big Bang afterglow that continues to hum through, though the entire sky would glow if you could see microwaves in the universe today with the warmth of that old fire. But there were no stars in spite of it. At this time, galaxies were a dark, expanding cloud of gas that had not yet become the universe, and promise, if you were to float through it, all you would perceive would be faint ripples. Minute imperfections in the matter's otherwise uniform dispersion. These ripples, which were whispers of quantum fluctuations from the very beginning, were everything. Universe by inflation, with some areas being only marginally denser than others. That difference. But gravity is aware of it and remembers it over time. Slowly but surely, the denser pockets of helium and hydrogen started to draw in more and more material. The seeds of the future are clumped together like cosmic dew on a spiderweb. If there had been eyes, galaxies would have been completely invisible. Yet it's a little odd to consider that we're already laying the groundwork for all the spectacular drama that will follow. The universe was calm, but in a sense, there was no starlight or glowing during this time. Only the subtle sound of matter settling into itself in galaxies. It was a period of calm before the storm, taking a deep breath before the universe let it out, even with all of our telescopes and calculations. Starlight, and yet we're still assembling the events and determining how these slight variations resulted in the expansive. Why did some regions of the cosmos experience the splendor of spiral galaxies, become vibrant centers of stars, while others stayed huge and gloomy gaps? The solutions are inscribed throughout the universe in each luminous nebula, and we simply need to keep listening to the universe's primordial star cluster. As dark matter expanded, the unseen structure of reality started to pull and mold the hydrogen, creating structure drawn into filaments by gravity. The universe complied with the whisper, and the first stars would soon flash. The blackness would eventually fade into life. But for the time being, the cosmos was set up. Was starting to transform into something more than just expanding. The stars hadn't found, but the galaxies continued to sleep. And for a few 100 million years, despite this, the universe continued to be shrouded in what are now known as the cosmic dark ages. Foreboding name, other from dragons. There were no knights or castles in this place. The type composed of hydrogen and plasma. This was the purest form of darkness. Don't feel that after the Big Bang's spectacular explosion. The cosmos is full of matter, but not yet light. The cosmic microwave background's gentle radiance and the opening act caused everything to settle into a quiet, neutral hydrogen gas. Enveloped the room like a huge, invisible cloud through which no stars could shine. The absence of distant galaxies meant that the cosmos had become dimmer, not because Earth had not yet discovered out how to turn on the lights, so it was lacking energy. Imagine a sea of chilly hydrogen that is endlessly expanding as you glide through time, and helium, with the occasional electron gliding by like a slothful jellyfish constantly being pulled by gravity. Cloud formation, here and there, but everything progresses at a very gentle pace. At that time, glacial pace meant that there were few clocks, no sunrises or days. Only the gradual, methodical buildup of bulk in ether world wasn't in a rush yet, but something remarkable was subtly, as you can see, during inflation. The foundation for all we know was being established in this murky stillness. Tiny quantum fluctuations were present in the lightning-fast expansion immediately following the Big Bang. These little variations in density, stretching throughout space, weren't particularly noticeable at first, but gravity eventually noticed when matter grew slightly denser. It started to attract more of itself over these ripples developed into the tendrils and knots that we now refer to as the cosmic web over hundreds of millions of years. Imagine the cosmos as a huge sponge or even a three-dimensional spiderweb. Connected by dark matter and gas filaments. These filaments are where eventually galaxies would develop and be drawn into position by the tenacious hand of gravity. The gaps between emptiness, the enormous lonesome expanses of that. The heart of it all was a void where almost any stars would ever shine. The black matter of the silent companion doesn't reflect, glow, or interact with light at all, making it renowned for being challenging to study and somewhat horrible at parties. But dark matter's gravitational pull was vital. Effect molded the universe's structure, drawing common matter, like as hydrogen and helium gas, into position. Like the universe might have remained a murky cloud if there had been no dark matter in the hidden frame beneath a picture, forever now. If you're still conscious, and if so, I respect your commitment. One may question why it took so long for the first stars to show up. It takes more than just putting gas in a blender and turning on the sun switch to create a star. Hydrogen must fall into pockets that were sufficiently dense to allow gravity to crush it. Until temperatures reached millions of degrees, could the nuclear dance that illuminates a star be initiated by fusion. But because the universe wasn't in a hurry, gravity was able to coax gas into ever denser clouds, which gradually and patiently fell apart. The first spark would fall under their own weight, someplace in one of those thick knots of substance, light a lone beacon in the sea of darkness. And when that occurred, everything altered. But in this extended period of quiet, the universe before the first note, the components were in place, but it was still taking breath, like an orchestra tuning. However, the music had not yet started, and there were no stars or galaxies. Increasing stress, a feeling that something lovely was going to occur, and despite the gloom, that might be the most consoling aspect of our time. Under the hush of its dreams, the universe was never really still. As the light was approaching and preparations were being made, something happened elsewhere, deep within a helium and hydrogen cloud that was compressing. Gravity strengthened its hold, temperatures rose, and pressure surged in the middle of that thick, unseen whirl. Atoms were forced so closely together at temperatures of millions of degrees that their fundamental nature started to alter, and was most likely invisible at the time. The first light to emerge following the Big Bang was an unceremoniously birthed star, known as Population 3 stars. These were not typical stars. Rather, they were everything we see now as huge, unstable, and extremely hot. They originated in the universe was at its cleanest state ever, with no heavy components. Remaining elements include carbon, oxygen, iron, hydrogen, helium, and a little amount of lithium. This caused the stars to burn brighter and quicker than the ones we know from the Big Bang. In the short term, some might have been hundreds of times as huge as our sun. Fierce lives before bursting in dazzling flames or falling into dark holes, supernovae. Let's face it, you would be really crispy if you were floating close by. In a broad cosmic field, you would observe these earliest stars illuminating their surroundings like bonfires, woodland, one by one, as their light broke through the old hydrogen fog that had filled the cosmos from the beginning. But gradually the darkness started to fade. This time frame is known as cosmic ionization, and although it seems like something a villain from science fiction might try with a ray gun, it was a calm. But the ultraviolet light from those nascent stars started to strip in a dramatic way. Neutral hydrogen surrounding them is ionized by electrons, creating universe transparent once again, as if someone had opened a cosmic greenhouse's shutters and allowed from our vantage point. The light floods in, but billions of years later, we are unable to see these early stars. Were too short and too far away, and their light was also their fingerprints are everywhere, albeit they are faint. They changed the cosmos. They sowed the universe with the first seeds, changing it from cold and dark to warm and radiant. Everything more complex than hydrogen is made up of heavy elements, including you, me, and the cup of innocence. These stars were the universe's tea, which you may be drinking now. The outlines of galaxies were initially drawn by artists on the empty canvas of space. However, these early stars were frequently scattered, Since galaxies had not yet fully formed in little groups that are connected by gravity but do not yet form the greater days, night sky is filled with swirling cities of stars, which were more like a community proto-galaxies that might be experimenting with structure and cohesiveness. But as these enormous stars came to a conclusion, the components were coming together. Heavier metals into the nearby gas clouds during their dramatic supernova lifetimes, which enriched when clouds cooled more effectively. They disintegrated more quickly and produced stars with more than. The second generation of stars started to emerge. The great cosmic cycle is smaller, slightly more stable, and already more known. Started when gas stars are drawn together by gravity, shine, die, and disperse their enhanced materials that enable the formation of even more stars every generation. Building on the, you may question if the ashes of the previous layering complexity resemble stardust sediment. If we have never seen these ancient stars, how can we know that all of this occurred? The solution can be found by examining the light patterns that resemble phantom fingerprints left on the cosmic windowpane. Oldest galaxies, the dim glow of ancient stars, and the chemical traces of astronomers can reconstruct the universe's early history using the cosmic microwave background in It's similar to reconstructing a forest's past by looking at its oldest trees, soil, and orientation. Of the breeze, the hints are subtle but present, and we've only started to pick them up. Using telescopes like James Webb, we're finally beginning to catch a glimpse of the first galaxies to form were tiny, erratic, bright clusters of stars from we are looking into the nursery a few 100 million years after the Big Bang. It's very humble where the first light emerged, before our solar system was ever a fantasy. These stars lived and died for billions of years. Light traveled through space, crashing into galaxies before it passed the expanding Milky Way and wandered past black holes until gently landing on Theia telescope's mirror aimed at the sky. And it now resides in your thoughts and as you fall asleep in the calm of your evening. The universe that was previously dark and silent has sprung to life. As the night came to a close and the era of galaxies was ready to begin, the first lanterns, instead of being brilliantly incandescent, the universe was now glimmering like the first glimmer of dawn on 8 was a chilly morning when the stars came out, their brightness dissolving the fog and warming things. Yet they were dispersed and flickered in the darkness like faraway camphias with only lonesome slivers of light dangling in the absence of cities and roads, empty space. But gravity had different ideas. And those dispersed stars weren't merely floating. Everywhere you looked or would have looked, they were being gathered together at random by unseen threads. Small clusters of stars were visible. If you possessed the patience of a cosmic being and a means of seeing ultraviolet light, they were subtly being threaded into bigger, more intricate structures by convergent gravity. The towns were turning into cities. The villages were turning into towns, and these proto-galaxies were the earliest examples of what we now refer to as galaxies didn't form smoothly. There were no cosmic engineers' markings or blueprints. It was disorganized, with clusters colliding, merging, and tearing one another out of our spiral arms with rulers. The early universe was a rough local gas that broke apart, and then merged. Again, stars were hurled from one group into another as clouds collided. While some early galaxies stopped, others rapidly became fat on neighboring gas and devoured their neighbors. At this point, they are stuck in peaceful areas of space like cosmic wallflowers. Galaxies did not resemble the graceful spirals or enormous ellipticals found in the gleaming telescope. Images were jumbled and erratic, less sophisticated than the symmetrical beauties you could think of, more like space blobs. However, despite their turmoil, they were gradually developing, and their shapes started to stabilize, influenced by their surroundings and pushed by gravity throughout a large portion of this Earth's even greater structure. The cosmic web had an impact on architecture. You can think of it as Athic knots where strands of matter are interwoven in a gigantic three-dimensional lace throughout the universe. The areas where galaxies would congregate were the hubs where dark matter intersected, similar to seeds discovering the best soil. Lengthy tendrils extended between thumb-drawing galaxies along unseen gravitational trains, and between these imagined enormously silent and unsettling expanses where a few galaxies would ever. Early galaxies had the most to gain from these intense interactions. And the biggest worry is that when there is a lot of gas and gravity in one area, things can go in a slow-motion dance. A few dramatic galaxies would collide with one another. Stars themselves did not collide violently as one might anticipate after hundreds of millions of years or so apart, that the majority didn't come into contact with anything but their gravitational fields did not. The tidal forces. Streams of stars were drawn like taffy trails, forming odd forms. Gas clouds clashed behind their original homes, compressing violently and causing fresh waves of star formation, which astronomers affectionately refer to as causing new clusters to form and new stars to blossom amid the tumult. The final shape was determined by the moment that what had been a shapeless cluster started to resemble something more familiar. Of a galaxy is still up for debate, but we do know some facts about galaxies that remained mostly unaltered and with the correct amount of spin may flatten into graceful spirals like to our own Milky Way. Others were smashed by collisions or developed in more crowded settings. Evolved into circular, puffy groups of older stars, ellipticals, and some just never really settled down. Those are always uneven and spotty. To be honest, we adore irregular galaxies for their frantic energy, but even due to their irregularities, galaxies have evolved into something novel. They were long-lasting star forges, where gas and gravity combined to inspire creation within stars that were born, lived, and then died, releasing their ashes in the process. Adding iron, carbon, and oxygen to the interstellar medium will enrich the galaxy, for the next planets were formed by the recycling of stardust over billions of years, moons, their atmospheres, and eventually a tiny blue world where, when someone whispers these tales into a microphone one day, it's easy to forget about the night. The length of time galaxies have been forming themselves is demonstrated by the stars you see now. Frequently, inventions from the second, third, or even fourth generations galaxies, remnants of long-dead ancestors, are like the universe's family albums, with each star representing a page. Every gas cloud is an unwritten story. And as galaxies expanded, they've started to create organizations, communities, and clusters. Unlike galaxies, which are made up of stars, superclusters are not. They orbit each other, affect each other, and frequent life will smoothly into one another's arms over the ages in which our own Milky Way exists. Such a group, in a peaceful area known as the local group, where it shares the sky with the Triangulum Galaxy and Andromeda. Numerous smaller pals, but it is a tale for another time. The cosmos had achieved yet another milestone, and it was no longer merely a sea of light and gas. It was organized, complex, and had neighborhoods. The universe had started to arrange itself, and stars had found homes. By this point, the cosmos was far from being empty, and some shy galaxies had formed and compact, while other stars moved in vast circles, sweeping and spectacular. The blackness remained, but the gas clouds glistened. With newborn light. Had moved away and retracted like a cosmic curtain to unveil the magnificent stage of creation. And galaxies had started to locate their form. Galaxies vary widely in shape and are not all the same. If snowflakes weighted a few 100 billion, their sizes would be similar. Some suns are squat, while others spin gracefully like pinwheels stuck in space. Some people bless their hearts, and they nevertheless appear round like celestial dumplings while riding a roller coaster. Someone attempted to sketch a galaxy from memory, but how do these shapes form? The explanation for why some galaxies are spiral while others are elliptical or irregular is always: let's begin with the spirals, which require temporal gravity and a great deal of cosmic patience. The galactic universe. Spiral galaxies displays are some of the most. The universe's lovely structures are the ones you see on science posters and desktop wallpapers. Films with the lovely curved sound of violins playing in the backdrop, luminous cores and arms like cosmic hurricanes caught in mid-air. We reside in a spiral galaxy in the Milky Way, which is our own cosmic home. Tend to contain a lot of gas, like a suburban dot on the rim of a massive revolving city spiraling into one of its arms, and dust, which are essential components for star formation. Therefore, their arms are ablaze with brilliant young stars that resemble festive fairy lights. Motion is key to a spiral galaxy's structure. Gas in a galaxy is said to have modest angular momentum. When stars rotate in a reasonably ordered manner, they naturally flatten into a disk over time, compressing gas as density waves ripple through it. Voila, spiral arms and sparking star creation seem, but they're not stiff structures. But the galaxy's patterns flow like traffic jams in all those stars travel in and out of space. The arms remain, but obviously not all galaxies are able to enter the elliptical galaxies with such grace. These galaxies lack spirals and are older, rounder, and generally more relaxed. Arms, but rather resemble enormous star clouds in the form of spheres. Or long rugby balls are typically made up of older, redder stars. If spiral galaxies are busy cities, there isn't much gas remaining to create new ones. Sleepy retirement communities. Elliptical galaxies are remarkably stable, and the formation of ellipticals is probably due to galactic mergers when two spirals collide with one another, particularly when they are similar in size and ordered. The stars are hurled into arbitrary orbits, motion is disturbed, and gas is depleted. Or blown away, leaving behind a large, formless mass that is striking, chaotic, and strangely constructive. Like to crashing to snowballs in the cosmos, there are irregular galaxies once the globes come together and let the flakes to settle. They are the oddballs that don't readily fall into any group. Some nonconformist galaxies are young ones that haven't had time to develop a shape, while others are older ones that have become somewhat. They were dragged out of alignment, like a hat blown askew in the wind by an irregular galaxy that was near a larger neighbor. May appear to be splatters or scrolls, but they're frequently brimming with fresh, vibrant stars, and it's possible that certain galaxies fall in between spirals with large bulges. Galaxy classifications, such as ellipticals with rings and various hybrid types. Even though astronomy can be as chaotic as the cosmos, we nonetheless attempt to categorize things, primarily because that's how people want to interpret everything. including the stars and dove fact. The shape of galaxies tells us something essential that goes beyond their aesthetic appeal. Regarding a galaxy's past, a spiral galaxy most likely had a more tranquil and stable upbringing. There may be a few minor mergers in the gas inflow, but nothing very painful or elliptical. Likely witness conflict merging with other galaxies in a sequence of cosmic unusual collisions could simply be the result of their youth, bad luck, or both. The fact that galaxies still undergo shape changes, such as spiral galaxies, is remarkable. Can merge to form giants, or tiny galaxies can become ellipticals. Their limbs are pulled by gravity, which also twists their cores and disperses their nothing in the universe. Particularly anything as dynamic as stars is static. The Hubble Space Telescope provided us with the best view of this cosmic because of its diversity. We have witnessed galaxies at every stage of development, starting with small protogalaxies from magnificent spirals and enormous ellipticals in the early universe to in the neighboring cosmos. We have observed galaxies colliding, stretching, and tearing. Each galaxy has a story to tell about their post-event reconstruction, and the language of shape is occasionally used to write that story. So the next time you see an illustration of a galaxy with a brilliant elliptical halo and a flawless spiral with blue arms or a disorganized cluster of stars, be aware that you are viewing billions of years of history, a tale of light and gravity, Africa's clouds flowing, colliding, and growing older, with stars created, aged, and gone when they were galaxies. They remembered more than just shining. Let's take a moment to return home. We have been traveling across the vast cosmos, following the formation of stars and elegant galaxy development. But it's time to head back to our region of the cosmos. Is a familiar place, but not because we have seen it from the outside. We have attempted, but since it is the location of every sunrise, every sigh, and every human tale, revealed that the Milky Way galaxy, in which we reside, is a formidable hostess from a location within it that prevents us from seeing the Milky Way in its entirety. It's somewhat like we can see a glowing river when we attempt to read the label from within the bottle. Bright light spanning the night sky, particularly discernible in isolated locations far from the radiance of urban areas. That glistening ribbon of dust and starlight is gaze over billions of light years across the galaxy plane. The Milky Way galaxy is a spiral galaxy, and it's a big one at that. It includes anywhere between 100 and 400 billion light-years. It's quite difficult to count stars when you're stuck, which is why the range inside of them, using a telescope and a variety of instruments to gaze out through dust clouds. Patience. But the most accurate calculations put us in the Orion arm, around 1/3 of the way from the center. Like cosmic suburbanites, who live far enough away from the action center, but not too near to the mayhem of the Milky Way, is a bustling, vibrant region that contains an enormous black Sagittarius. It is a gravitational heavyweight hole that is about 4 million times our sun's mass. Is not the brightest thing in the universe, and it doesn't consume as much as some of the black holes, but it serves as an anchor for the entire galaxy, with stars swirling around it, whirling circles that resemble moths circling an unseen flame that we are aware existence. It is directly visible to us, but because of the way it influences its environment. Picture watching stars move. Astronomers have been following them for years, and the evidence is that they appear to be trapped in an invisible vortex. Make room for something enormous, terribly small, and extremely hungry. Is positioned at the galactic center. And no, it has no intention of devouring Earth like all galaxies. The Milky Way didn't always seem the way it does now, has a lengthy and sometimes tumultuous history. It was formed over billions of years. Smaller galaxies were drawn in by mergers and acquisitions in the business jargon of cosmology. In spiral stars, after being broken down and folded from these galaxies, continue to circle on vast loops in the Milky Way's outer halo. Roots like roving ghosts from long-lost homes, and it continues to this day. The Sagittarius dwarf galaxy is one of the tiny galaxies being torn apart by the Milky Way as you listen. Is being gradually disassembled and assimilated, for example. This is not a violent process. Over millions of years, rather than on a human timescale. It's similar to witnessing ATO make the Milky Way even more spectacular. A drop of ink slowly swirls into a pool of water. On a slow-motion collision track with Andromeda. Our closest big neighbor galaxy is now traveling straight forward at a distance of roughly 2.5 million light-years, at about 110 kilometers per second for us. But don't worry, you have roughly 4 billion years to prepare. And it won't be the end of the world when it does. The two galaxies will actually probably combine to form a new one, perhaps an elliptical one. Even the name Milka, which, to be honest, sounds like a brand has been proposed by galactic astronomers. Of space yogurt. But we'll overlook it because it's incredible that we can communicate all of this from our position inside the galaxy using infrared radio telescopes. Through careful calculations and measurements, we have been able to trace the spiral arms. Track the populations of stars and even model the genesis and destiny of the galaxy. It's similar like assembling a jigsaw puzzle from the inside out and discovering that the final piece is far larger than you ever envisioned. And despite all, the sun continues to revolve our tiny star. Approximately 225 million years are needed for the sun to complete one orbit around the center of the Milky Way, which indicates that since the sun formed, we have only traveled around it roughly 20 times. Reference: the dinosaurs were just starting to roam the Earth when we were last in this galactic neighborhood. It turns out that galactic years are calculated in epochs rather than birthdays. Thus, we find ourselves silently drifting in a pale blue spiral arm of the galaxy, wrapped in the gentle light of a billion stars. A dot circles an ordinary yellow star. All of your body's molecules and atoms were formed by living stars died a long time ago. Perhaps in galaxies that were subsequently incorporated into our you are actually a living, breathing component of the Milky Way story, the result of star stuff. Listening to a piece of galactic history, the galaxy is not only outside of you, it is within of you. If galaxies are the universe's big cities, then who or what constructed them, established their unseen bases, maintained their stars' orbits, and made sure they didn't split apart in the breeze like dandelion seeds since the beginning? Our three improbable architects have been working in silence. Black holes, dark matter, and gravity aren't exactly a pretty combination. Maybe none of them sings, sparkles, or receives invitations to birthday celebrations. But the universe would be a terribly formless and empty place without them. Yes, let's begin with gravity. The most enduring and well-known force of the Great Gatherer is group gravity. It doesn't yell or cause a scene. Pulls just have always had will. When the universe first started to expand after the Big Bang, gravity was the cause of things starting to eventually it started to magnify the smallest flaws and ripples in the density of space, bringing dark matter and gas together to create stars and galaxies. It never stops functioning if you are slow and patient. But here's the thing. Gravity of the four basic forces in physics, relentless is actually the weakest. It isn't very strong. Hold a paperclip over it, and gravity will draw it to the ground. The paperclip easily overcomes gravity when a modest magnetic field takes over. Resists the gravitational pull of a complete planet. Therefore, why does gravity shape the cosmos? Since it never balances itself out and instead keeps building up. The more mass you have, the more gravity you experience due to electric or magnetic forces. And in the immensity of space without air resistance or friction breaks it, while gravity's silent perseverance mounts up. There was a mystery when astronomers truly examined galaxies. Something was missing. When they calculated the speed at which their stars were spinning, they discovered an oddity. The outer stars were located far from considering the apparent mass of the galaxy. The galactic center was traveling far too quickly. The galaxy, they should have been thrown like glitter from a spinning wheel into space. But instead they stayed. This was an issue unless there were more loyal, orderly, stable mass than what is visible. To us, much more enters dark matter, a substance that is invisible to us. Although touch cannot smell. We are very positive that there is one because the universe is filled with gravitational fingerprints. But dark matter doesn't interact with them. It doesn't glow when exposed to light, but it does exert gravity, and there is a lot of it, around 5 times the mass of dark matter compared to regular matter, which implies there is a considerably larger invisible star or gas cloud in every galaxy that is visible. Think of a galaxy as a blazing halo of dark matter that holds everything together. The dark matter halo is bubbled by a gigantic unseen bubble in which jellyfish swim. Is what prevents the jellyfish from separating in the absence of known dark matter galaxies. They wouldn't have created in the first place if they couldn't exist, and if they somehow, stars would have flown away if they hadn't stayed together. Instructions and the stunning spiral arms that we greatly like would never serve it to this day. Nobody is certain what dark matter is, but there are many theories incorporating exotic particles, supersymmetric partners, and even more dimensions. However, none have been verified, but its consequences are indisputable, such as we can tell that there is wind on the ocean without actually seeing it, as if we reach the final member of the triumvirate, black, as if galaxies weren't already full of secrets. Holes, not just any black holes, but extremely large ones, monstrosities which vary in size, are found at the core of almost every massive galaxy we have examined, including our own. Although they are thought to be destructive, they are actually millions to billions of times the mass of the sun. Rather, like galactic administrators, who are quite enigmatic and highly. We once believed that extremely large black holes were merely passengers that happen to form in the center of galaxies. But in recent decades, we've come to understand that they're more like Kothors, the tail of a galaxy. Their development appears to be linked to that of the surrounding galaxy. When they consume gas and dust while feeding, they emit massive volumes of energy that can blow away, which is frequently greater than the total energy of the galaxy's stars. For millions of years, the gas required to create new stars stopped star formation. In other words, black holes control rather than merely exist as cosmic drains. Growth. They influence galaxies' destiny through a mechanism known as feedback. Although research is ongoing, it is evident that extremely huge black holes have the ability to affect their surroundings on enormous scales for millions of light years. plasma jets can stretch, sculpting the intergalactic medium and changing thesta flowing across a galaxy. It's somewhat paradoxical that the darkest objects in the ones in the universe that suck light and avoid our eyes are also the ones that keep everything together. Black holes, gravity, and dark matter, the unsung creatures of everything. And now we find ourselves in a spiral galaxy, orbiting a star, encircling an extremely huge black hole in a dark matter halo that will never every action we perform. Every breath we breathe, all of it occurs in a universe that is held together by unseen hands, so keep it in mind the next time you look up at the stars. The unseen framework is the remainder of the story. The beauty you see is just part of it. The calm gravity and silent forces that hold everything together still exist, not glowing, not talking, but always building in photographs. Building galaxies may appear calm with their elegant spirals and brilliant halos, beautiful dust lanes. But don't be fooled, the universe isn't a peaceful place. Galaxies are continuously traveling and orbiting in the IMMENSITY. Like dancers in an endless waltz, drawn by gravity. And sometimes those when dancers approach too closely, their arms entwine, their pathways intersect, and they collide in a leisurely, breathtaking ballet that develops over time rather than with a loud crash. Indeed, galaxies collide with one another for hundreds of millions or possibly billions of years. However, before you see planets colliding like marbles and stars exploding, take a even though galaxies are large, the reality is more poetic. The distance between empty space, stars is so great that even in a full-blown cosmic collision there is very little likelihood that two stars will actually collide. It's like watching two banks of fog flow past one another. But the fog is composed of dust, gas, and stars, while dark matter is whirling in gravitational fields. Even if individual stars may avoid direct collisions, galaxies do not come out of them unaltered. When two galaxies collide, their gravitational attraction causes them to stretch and deform their forms into lengthy, flowing star tendrils. These are known as tidal tails, and they like luminous streamers unraveling into space, and each one can span hundreds of thousands of light years. On the other side, a trail of stars thrown outward by the encounter gas clouds are less fortunate, because they collide with gusto, crushing, heating, and frequently causing a spectacular outburst of star formation. Known as a starburst, there is a cosmic baby boom occurring when galaxies manufacture stars at rates dozens or even hundreds of times faster than normal. Inspired by the tumultuous forces of gravity, some of the most exquisite and we have seen chaotic galaxies that are captured in the middle of collisions with antennae galaxies, such as twin spirals merge. They display long curving arms of stars and bright areas where new stars are forming. They provide a glimpse of what occurs when galaxies discard each other's personal space, and the two galaxies will finally come to terms. Spiral constructions are frequently transformed into one that isn't a spiral anymore. After a significant merger, the outcome is delicate and too easy to disturb. Stars in a big elliptical galaxy typically have randomized ordered orbits. When the gas that was released into intergalactic space or used up in the starburst is no longer, this is how many of the biggest galaxies are so abundant that they can create stunning new arms in the cosmos, originated from gradual accumulation rather than peaceful accumulation. Tectonic plate collisions cause motion crashes that resemble cities. But this isn't only ancient. The Milky Way has its own history and is not merely a passive viewer of it. Collisions to consider at this time as our galaxy is gradually merging. The Sagittarius dwarf galaxy is one of several smaller dwarf galaxies currently making spectral circles across the Milky Ways after being torn apart and absorbed its star shallow. Other minor galaxies are following comparable processes of digestion, restructuring, and folded into our own. And Andromeda, our closest massive neighbor, comes next. Although the Andromeda Galaxy and the Milky Way are 2.5 million light-years apart, they are headed for collision. Traveling at a speed of roughly 110 kilometers per second, which may seem quick, but in the collision won't occur for galactic terms because it's a slow and elegant approach. Another 4 billion years or more, but the outcome will be amazing. Surprisingly little, at least in comparison to the scope of Arndt's more. The solar system stars are so apart that direct collisions are improbable, but over millions of years, the night sky will shift. Andromeda will gradually take up the two galaxies' perspective as they get bigger and brighter, will converge and form a new shape, perhaps a gigantic, by twisting around one another. Astronomers have affectionately termed the impending union an elliptical galaxy. Yes, Miller, there are times when scientific naming is just whimsical, but even before collisions continue all around us in dense galaxies as that big dance starts. Clusters constantly interact, distorting their structures and stirring their gas. Galaxies are not static islands. They are a component of the universe's life cycle. Like everything else, they develop, grow, and change via relationships. What's so intriguing about nature is that these interactions aren't merely they can restart the star formation feed through creative mergers, which are often devastating, core black holes, and rearrange galaxies' constituents in ways that result into completely new constructions, such as cutting a tree or combining two paint colors. The outcome is a me think fresh, first, untidy but frequently more colorful than previously, and in this collisions in the constantly changing universe are the norm rather than the exception. We often imagine the world to be serene and static, like an endless night sky with frozen stars, but its living galaxies are mingling their light as they wander and collapse into one another. Even now, there are two stars in their stories. The long, languid dance of galaxies will eventually clash, but not in violence but together. A new galaxy will emerge, as it always has. Looking into space is looking into time, and it always will be. It's one of the universe's quietest, most astounding facts about every star you view at night. Every galaxy in the sky that has been photographed by a telescope does not appear to you right now, Butho. It appeared in the light at the time, despite its incredible speed travels. Slowly in space is incredibly large. Thus, when we gaze up at we are literally time traveling through the stars, taking in the sun's warm light. About 8 minutes ago, you were walking in the late afternoon when you touched your face under the starlight. By the time it reaches Earth, it is almost 8 minutes old and the sun is never visible, as you can see. It moved beyond of our solar system, and the light from Alpha Centauri, the closest star system to us, increases with time, is older than 4 years, and it is illuminated by the ancient Andromeda galaxy. Started moving in our direction almost 2.5 million years ago. Long before written language, long before the wheel, the earliest people. The soft glimmer in the sky is a whisper and recollection from a time so far away that predates what we currently know, but with the correct resources, we can go far farther, can virtually reach the beginning of time, spanning billions of years. The more deeply it's like removing the layers of cosmic history one photon at a time as we move farther back in time. The Hubble Space Telescope is an example of how telescopes may become time machines. Launched in 1990, for example, and orbiting far above Earth's atmosphere, one of the most well-known things that Hubble has showed us is something we never thought we'd see. Accomplishments is the Hubble Deep Field, a straightforward concept. Astronomers directed Hubble toward what appeared to be a pitch black blank area of the sky they let it to stare for days, as if nothing was there. And when the picture threatened to find that everything had turned into a sea of galaxies, each with thousands of them, including billions of stars crammed onto a grain-sized patch of the sky. Some of the galaxies were over 13 billion sand grains at arm's length. Years ago, we were gazing back nearly to the time when galaxies initially appeared, started to form. That light had journeyed for almost all of the universe's age, traveled unthinkable lengths and passed by countless wonders before arriving at us and eventually touched down on Hubble's lens, creating a dim yet persistent trace. And now we have the James Webb Space, an even more potent time machine. With the deployment of the telescope in 2021, the Webb can view even further back in time. Not just despite having a mirror that is more than 6 meters wide, it is larger because it can see as the cosmos expands. Light from far-off galaxies is crucial in the infrared. Stretched, similar to stretching taffy, which causes it to shift to longer wavelengths. This phenomenon is known as redshift, indicating that the earliest galaxies now primarily emit infrared light, which Hubble might catch a glimpse of. A light web was constructed to bask in it, and it is already revealing galaxies that some are tiny and existed only a few 100 million years after the Big Bang. As we might anticipate, some people are erratic and chaotic, yet others are extremely mature. Similar to how fully developed towns emerged immediately following the construction of the first huts, our knowledge of how quickly galaxies formed is being altered by discoveries, which may possibly rewrite some of cosmic history. And the most poetic aspect is that the further a galaxy is from us, although it is actually younger, it seems older to us because we're regiven how things were billions of years ago. You could assume that it's true that we are constantly examining the past, but it's also how we discover we don't need to go back in time because the universe has already handed us its memories, one photon at a time, and we are using glass and gold to carefully and silently capture them. In a sense, science is listening to the past with a great deal of patience, better and better ears. But of course, there are limitations to all of this. Looking back at a moment when the cosmic microwave background is too far away for us to see. Though the Big Bang's afterglow doesn't mean that nothing existed before it, but rather that before then, the universe was opaque. Light was confined and dispersed and couldn't move freely, like fog in a thick forest. Light didn't break until the cosmos cooled and atoms created, free and start its lengthy trek to us, which is the edge of our cosmic horizon. Visibility as well as beyond that enigma, potential queries that we are currently working to address. But what we do have is amazingly, every picture on the internet and every Hubble frame is a picture of beyond, a moment captured in time so far away that it seems like fiction, but it's that light is genuine. It once touched a cloud, a galaxy, or a star. It affects you now because of the gas. So the next time you look up at the night sky, keep in mind that you're gazing back, way back, not simply up. Although stars continue to shine, Many of them did so when Earth was young and there were no eyes to behold, names to give them, yet their brilliance continued to transcend time and space too. Now that I've found you, the universe is more than just a storybook. It reminds them that we have come a long way from the first hints of matter to the weak have seen the universe light up, organize, and change as we have observed the vast spirals and luminous cores of galaxies. Now as we discover that the universe is far from complete, as we drift into the present, galaxies continue to form, merge, and reach out to one another across the cosmic void because, like people, galaxies want to congregate rather than exist alone. They create gigantic, incredibly large structures in groups, clusters, and even superclusters. Our own Milky Way is a part of one such assembly, the local group, which defies easy imagination. With around 50 galaxies, it's a comparatively peaceful region of the universe. The majority of them are tiny, dim dwarf galaxies that circle the bigger ones, such as Cosmica, of course. We and our neighbor Andromeda are the two biggest members of the neighborhood club. We are the twin giants of our small, slowly spinning galaxy. We have already discussed our future merger with one another. However, for the time being, the two galaxies keep a respectful distance from one another, close enough to observe one another without bumping into one another. However, there are many smaller companions all about us, some of whom are both enormous and small. From the southern hemisphere, melanic clouds are readily visible and are currently being dragged in. Others, such as the Ursa or the Draco dwarf, into our spiral arms. More elusive are minor dwarfs, which are faint clusters of stars that are just hanging on. Groupings like 2 hours are prevalent in their orbits across the dark matter halo of our galaxy. But they are only the start. If you zoom out, you can see groupings of galaxy clusters. Gravity holds hundreds or perhaps thousands of galaxies together, for instance. The Virgo cluster is crowded and located just outside of our local group, with ellipticals, spirals, and all other shapes in between. Galaxies aren't courteous on these settings. People from far away congregate, engage, and frequently collide, can practically sense the gravitational tug-of-war spanning millions of light years. These clusters are part of larger supercluster formations, such as the Lernia, supercluster. In its broadest extent, the cosmic address spans more than 500 million light-years and includes over 100,000 galaxies, each, with billions of stars traveling across space in unison, following the trajectory of gravity across a network that we're only now mapping. And even that's only a thread in the wider cosmic web, the enormous framework that serves as the framework for the universe. Galaxies develop rather than being dispersed haphazardly throughout space. Immense sheets and nodes that resemble a huge mass of foam stretched out over a pitch-black ocean. These formations, which were first conceived just after the Big Bang, have been molded over billions of years by the between these filaments. There is a steady pull of gravity and a faint nudging of dark matter. Voids are vast, empty areas with few galaxies. Some are silent, dark, and tens of millions of light-years across, with only a lone galaxy drifts through this area like a ship at sea. Contrast between densely packed areas and expansive gaps that the design of the current cosmos has revealed. But not everything is expanding. There are indications that the universe's great dance may be slowing down, not in motion but in many galaxies, particularly the large, mature ellipticals, are no longer creative. The gas required for stellar birth has been used up or lost by producing stars, which we refer to as tear red and dead because their stars are aging, not because they're dead. Emit a gentle crimson glow, and no new stars are taking their place. Not even our own Milky Way is creating as many stars as it used to by a wide margin. But the time of the frenzied star birth is over. We're in a more contemplative and peaceful period of cosmic life, and the cosmos' dark energy, which we still don't fully comprehend, is the reason it's growing faster and faster. Over the coming years, this enigmatic force will accelerate the rate at which galaxies are being pushed apart. It's feasible that galaxies that aren't gravitationally tied to us will completely disappear from vision in 1 trillion years. The universe will get quieter and colder as it is stretched until it can no longer reach us and increasingly isolated. But don't worry, there is still plenty of time for galaxies to continue to communicate, develop, and astound us with telescopes such as the Hubble James Webb, and we're seeing farther back in time and farther into space than those who have yet to come. Before, we could hear the echoes of galactic birth, the collision waves, the when Earth had oceans. The night sky was filled with the faint glow of young stars, and galaxies so far away is full of those echoes, and each shining dot tells a narrative, some of which are just being started, ceased a long time ago. Yet they are all a part of this enormous, lovely, the visible cosmos continues to paint itself, and galaxies are no longer merely mysteries. They are teachers, friends, and reminders that even we cannot comprehend the vastness of the universe. We are a part of it, and it is a part of us, and now, following billions of years and light years, we've arrived at we have strayed from the universe's origin to the galaxies. Birth at the end of our voyage. We have witnessed stars burst into life, clusters from the dark ages to the first light, through spirals formed by unseen hands, and into cities of flames. We've seen galaxies clash, merge, fade, and mature into silent, elderly giants in a living universe that never stopped moving. We have traveled through our own galaxy, the Milky Way, and experienced its pull of dark matter and black holes, the silent creators of all we see, and weave at ancient light that journeyed across the entire universe to meet was quite striking as you looked back in time. Knowing it now is humbling, isn't it? The stars above you are reminders that galaxies are more than simply spots of light. Stories are still being told, not just pictures, and everything around you, your hands, breath, and thoughts were fashioned in the heart of a long-dead star. And you are composed of galactic materials. You are a part of the narrative. And perhaps it is why the night sky is so reassuring to us, and why we feel calmer when we're gazy up, because we all have an innate sense of what it's like to float through light. So I'll ask again, as your eyes go weary and your thoughts become softer, just as I did when we first started. What time is it, and where in the world are you listening from tonight? I would love to hear your thoughts, so please leave a remark in the comments section. If you are, it reminds me of the places where these small travels are spreading over the world, how we are interconnected through wonder, curiosity, and stardust. And if you want to spend tonight floating through space with me, please like or subscribe for more drowsy science. I would love to travel through the entire cosmos with you. But let's relax for the time being and allow the stars to continue to watch and the galaxies to continue spinning. As always, good night, fellow travelers, and your home is among